6040 ACFS Travel System. My name is Jose Rodriguez, Technical Service Instructor. Part 2. Travel Motor. Each travel motor is equipped with an integrated travel retarder valve. 4. Travel retarder valve. 4. Prevents excessive rolling of the excavator when driving downhill, throttling the output side of the travel motor in such a way that there is always a certain minimum pump pressure at the inlet side. This minimum pump pressure ensures filling of the axial piston motor with oil. This ensures safe downhill driving by positive engagement and without cavitation. The pressure relief valves integrated in the motor protect the hydromotor against pressure shocks. Pressure peaks can occur during the start and stop phase of travel. Travel accumulator. 3. Helps control the pressure peaks. Travel motor schematic. "50 bar second speed, 400 bars shock relief valves, retarder valve, brake release valve." The travel motors, 1. Rotate the final drive, 2. Which transfers power to the sprocket, 3. And track, 4. The travel brake is located in the travel motor brake chamber, 5. Travel motor schematic. First speed reverse. Travel motor. Actuator piston. Schutel valve. 2-speed. Solenoid valve. Parking brake. Shock relief valve. Travel brake release valve. Retarder valve. Travel control valve. Travel control valve. This image shows the oil flow in the travel motor when the travel system is in first speed reverse. Oil from the travel control valve, 1. Flows through the retarder valve, 2. To the travel motor, 3. The shock relief valves, 4. And a shuttle valve, 5. The shock relief valves limit pressure spikes in the travel circuit pressure to 40,000 kilopascals, 5,800 psi. The retarder valve moves down and allows oil from the low pressure side of the travel circuit to flow through the travel control valve back to the tank. Oil from the travel control valve also flows to the travel brake release valve, 6. The brake release valve shifts, and oil flows to the parking brake. The parking brake, 7, is released, which allows the travel motor to rotate. The travel brake release valve limits the parking brake release pressure. When the travel system is in first speed, the 2-speed valve, 8, is shifted by spring force and blocks travel system oil. Oil at the bottom of the actuator piston, 9, flows to the tank. The actuator piston spring force moves the swash plate, which upstrokes the travel motor to the first speed position for more torque and less speed. Final drive. Final drives. 1. Air 3-stage wheel hub planetary gearboxes. Each final drive, 1, is driven by 2 variable displacement axial piston motors. Swivel. The swivel accomplishes 2 functions. The swivel carries circuit oil from the rotating upper structure to the travel motors in the stationary lower structure. The swivel carries pilot oil from the upper structure to the parking brakes, 2-speed operation, and the track tension system in the stationary lower structure. The swivel also provides a path to the tank for the return oil and the case drain oil from the travel motors. The swivel provides a path to the tank for the return pilot oil from the parking brakes, 2-speed operation, and the track tension system. Housing, 1, is mounted to the upper structure. Rotor, 2, is keyed to the lower structure. The ports of the housing are open to the ports of the rotor through internal passages. Swivel port. The rotary joint, swivel, routes oil from the travel system components on the superstructure to the travel system components on the undercarriage. The rotary joint housing includes numbers to ensure the correct connections are made to the channels. Oil ports on the rotary joint are: leak oil return, 1. Track tension, 2. Second speed, 3. Travel pressure, 4. Swivel taps pressure locations. A1RH track tension anti-cavitation pressure 1. A2LH track tension anti-cavitation pressure 1. B1RH track tension anti-cavitation pressure 2. B2LH track tension anti-cavitation pressure 2. C1RH track tension anti-cavitation pressure 3. C2LH track tension anti-cavitation pressure 3. EE second speed control pressure. Travel valves. Travel valve. Right. Travel valve. Left. Retarder. Valve. Anti-cavitation valves. The travel valves direct oil from the main pumps to the travel motors. The anti-cavitation, makeup, valves allow the return side of the circuit to supplement the supply side to prevent cavitation in the travel system. Travel tensioning system. Each track frame is equipped with a track tensioning system. The track tensioning system takes up any slack in the chain due to wear and cushions the system during traveling. During operation, the track tensioning system is supplied with servo oil, which acts on the cylinder piston in the track tension cylinders, 1, and charges the accumulators, 2. The accumulators are charged with nitrogen to 5,500 kilopascals, 800 psi, pressure. The accumulators act as shock absorbers for horizontal movement of the idler due to external forces. If an external force is excessive, the shock relief valves, 3, set at 33,000 kilopascals, 4,800 psi, limit pressure spikes due to external forces. The shock relief valves can be opened using the handles, 8. Turn the handles in to set the pressure to 33,000 kilopascals, 4,800 psi. The track tensioning block, 4, contains pilot-operated check valves, 5, and a switching valve, 6, which release built-up oil pressure in the track tensioning system. The isolation valves, 7, are used to isolate the track pressure to perform maintenance or to transport the track frames during assembly. Track tension system normal operation. During normal operation when the machine is traveling, the track tension cylinders, 1, and accumulators, 2, are supplied with an oil pressure of 6,000 kilopascals, 870 psi, from the servo pump via the servo valve block, 3. The pilot check valves, 4, remain closed. The shock relief valves, 5, limit the oil pressure in the tensioning cylinders to 33,000 kilopascals, 4,800 psi, during traveling or shock loads. Track tension system pressure increase. During the travel operation, pressure increases due to dirt in the track and other factors. The shock relief valves limit the pressure to 33,000 kilopascals, 4,800 psi. Track tension system pressure relief. If the machine travels for more than 15 seconds, the following occurs 10 seconds after the machine stops traveling. The servo controller energizes the track tension switching solenoid in the servo valve block. 1, for 5 seconds, which increases the oil pressure from the servo pump via the servo valve block to 8,000 kilopascals, 1,160 psi. When the pressure reaches 6,000 kilopascals, 1,015 psi, the switching valve, 2, opens, which directs oil to open the pilot check valves, 3, and allows oil pressure in the track tension cylinders, 4, to return to the tank via the relief valve, which is set at 8,000 kilopascals, 1,160 psi. After 5 seconds, the servo controller de-energizes the track tension switching solenoid and 6,000 kilopascals, 870 psi, is supplied to the track tension system to keep tension on the track. The track tensioning system increases the life of the track and undercarriage components. The end. Parsed 2 travel system. Courtesy of JLR Training Company.